Now that we've set up our grain simulation, it is time to create some collision geometry. So for now, we've been using a grid just to avoid the particles going to infinity, but we will need to create a terrain collider for our final render. So if you remember, we created a boolean from a piece of the terrain. So we created some depth to the geometry. We also booleaned out where the sand will be. And this geometry is perfect as a collision object for the floor. So let's set this up. I'm going to dive back into my DOP network. For now, we won't be using this ground plane anymore. So I'll disconnect it. I can press Y and just drag here. And I'm going to create a new static object. I will call this static object terrain and connect it to the static solver. Now, the first thing we need to do is point the object or the SOP geometry that we need to bring in. And here under the SOP path, we can look for the null that we created. It's called out terrain. And here it is. We have brought in the geometry. Now, what I usually like to do is hide the actual geometry and take a look at the collision object that is being generated for the simulation. So let's do that together. Scroll a bit down until you find the display geometry tick. So turn it off for now. And here under collisions, let's click on collision guide. So this will show the collision guide that's being generated by default. So if you press spacebar W, you can see the wireframe. So for now, it's kind of coarse. What I'm going to do is increase the uniform subdivisions to 100. This will create a more refined mesh and with much more detail to handle the collisions. So let's try this out. Make sure you're on frame 1. Press play on your animation. And it may take a few frames to settle. But after a few frames, the grains will stay still. Of course, nothing exciting will happen. We just want to make sure that they're not falling under the collision geometry. So let's stop and go back to our frame 1. One of the first things I like to do with the collision geometry is check its physical properties. So click here on the physical tab. And by default, we have a very high bounce. I'm going to bring the bounce back to 0.05. The friction is fine for now. So I think we are now ready to create the actual explosion. And there's many ways that we can create an explosion with points or with grains. We could add an initial velocity. That would be the easiest way. We could also add some velocities through Vex, as we did in the Vex course. But in this case, I'm going to do something different. I'm going to create a collision object that pushes the particles from the center out with a lot of force. So let's go back to the SOP context. And here to the right, I'm going to create a sphere. Make sure it is a polygon object. And I'm going to add some detail. Let me first zoom into the sphere. I'll select the sphere object and frame it. I will increase the frequency to say 30. I'm also going to bring the radius down to 0.5. That way we have a sphere with 1 meter in diameter. And I'm going to make it a little bit irregular with a mountain SOP. So just to add a bit of noise to the geometry and don't have a very even collision. You can increase the height a bit if you want. Now I'm going to bring this close to the origin of the grains. I'm going to add a transform. probably go to the top view, so press spacebar 2, press enter on the viewport just to display the transform gizmo. So I'll press T and just drag this near to the origin of the explosion. So let's template the chunks. And actually here I am, exactly above it. So now I'm going to press spacebar 4 just to see from the right view. And I'm going to bring this boulder down by about a meter. We will need some test simulations to get a feeling of how big this needs to be. But for now, let's leave this like this. And let's add another transform to create the animation for the rock. So let's call this first transform initial position or initial pause. And let's call this one anim for animation. And I usually like to change the color of the nodes that I animate to green. So let's do that. And here on frame 1, I will create a keyframe for the position or translation. So you can right click, go to keyframes, set key, or simply Alt and left mouse button to create a keyframe. So I will also create some keyframes for the rotation. Now I'll go forward about 6 or 7 frames. Now I will translate this boulder upward. And here a problem that may arise is that the falling particles may fall down again onto this rock. So I will go to frame 8 and pull it down again so it doesn't collide with the rest of the falling particles. So let's go back to our camera view and let's bring in this geometry as a collision. So let's add a null. As usual, let's change the color and the name. We'll call it out collision geo. Go back to our sim. So dive into the DOP network. Make sure you're on frame 1. And I will create another static object. This time I will name this collision. And we will need a merge here. So add a merge node. That way we can use both collision objects in the same static solver. Now I'm going to do the same thing that I did with the terrain. First of all, under the sub path, I'm going to look for the null called out collision geo. Turn off the display geometry and again bring bounds down to 0.05. For now, let's leave the friction as it is and let's turn on the collision geometry. So click here under collision guide to turn it on. And I think we're pretty much ready to create some tests. So make sure you're on frame 1, press play, and let's take a look at the first result with the collision geometry. Okay, so I'm in frame 20 and nothing has happened. So let me move down just to take a look at the geometry. And if you take a look here, the rock hasn't moved from its original place. And if you go back to the static object node, I forgot to turn on use deforming geometry. Since this geometry is moving, we need to turn on this option. Otherwise, as you just saw, the object won't move. So let's try that again. I'll go back to frame 1. Take a look through the camera. and press play. Okay, so now we know it's working. Of course, the explosion is huge. The force is tremendous right now. So we will need to work with the velocity, the speed of the boulder. Let's also try checking the scale of the boulder and see if we can get a better reaction for the sand. So let's go back to the sub context. What we can do is just increase the animation time. So first of all, I'm going to change the animation length. I'm going to bring down the end frame to 60 frames. Actually, I'm going to type 40. We probably won't need more than 40 frames. And now I will extend the length of this animation just to make the motion slower, and thus the force will also be lower on the grains. So I can press Shift, click and drag to create a selection of keyframes, and then middle click and drag to the right just to move these frames a little bit and have the rock move much slower. Another thing that I'm going to do is decrease its radius. So actually I'm going to decrease the uniform scale to 0.5. And let's take another look at the simulation to see how it's reacting. Okay, so this is much better. It's still traveling way too high for my taste. So another thing that I noticed now is the rock is probably traveling too high and pushing the grains too much. So I'm going to do a fast tweak on that. We can do that together right now. Select your transform node, go to frame 12, and bring the rock down to say 1 meter. And let's try now. Go back to frame 1 and let's create another test. So one quick tip here, if you notice I'm going back and forth with the rock and the top network. You can press Ctrl and 1 to set a quick mark on this view. Then go into the top network and press Ctrl 2 to set another quick mark inside this node. And then you can press 1 and 2 to jump from one view to another. So that is quite handy when you're going from one view to another. Now let's create a quick test. So apparently the rock is not even hitting the grains. Go back here to the animation, bring it up, say to 1.7, and let's make one final test before we move on. I think this view is better just to see what the rock is doing. And that's definitely much better. So let me take a look from the camera. I will create a quick flipbook. And be back in a second.